All right, Universal Fire.
In Universal Fire, it starts off talking about a piece of fiction, a book where Harold Shea is transported from our own universe into the universe of Norse mythology. This world is based on magic rather than technology, so naturally, when he tries to light a fire with a match brought from Earth, the match fails to strike.
Bum, bum, bum.
Eliezer has a problem with this. Eliezer says that Antoine Laurent de Lavoisier, I think?
Yeah, pretty good.
Okay. Discovered fire. His great innovation was to weigh all the pieces of the chemical puzzle both before and after the chemical reaction. So he discovered that all the parts, including the weight of the air after a fire, are equal to all the weight of all the parts before. He also knew how to separate gases and discovered that burning a candle diminished the amount of one kind of gas, which they called vital air, and produced another gas called fixed air. Today we would call them oxygen and carbon dioxide. When the vital air was exhausted, the fire went out. And he said that the thing that's really amazing about this is that way back in the day, when people didn't know how their bodies worked, like not on a real deep level, like you could look at your hand and flex your fingers and really have no idea why that worked. Like, I mean, you know the muscles are doing work and moving them, but why are your muscles contracting? How is any of this possible? It must be the soul inside you, right?
Yeah, why does your hand move and not like a piece of clay that you're holding that's shaped like your hand or something?
Yeah.
Which like all seems kind of obvious to us now because we all took elementary school science and stuff.
Mm-hmm.
But just a quick side note there, anyone who hasn't read anything like on a history of science, I think it's worth like just grab like something like a brief history of nearly everything, and there's an audiobook version of that too. But just putting yourself in the mindset of somebody who didn't know all this stuff already. Because, like, you look at it now and be like, oh, chemistry is boring. It's like, do you have any idea how, like, weird it was to live in a time when you didn't know what stuff was made of? Yeah. Like, now we know, and it seems like that's something that humanity has always known, but we've only known for, like, a few hundred years that, like, stuff's made of atoms, right?
Yeah.
So, I think that sort of thought experiment, which you can run by reading a history book, is, like, just vital to getting the wow of science.
Yeah.
And to make something like this make more sense.
And that's where he points out, imagine not knowing all this stuff and then discovering that humans, in the course of breathing, consume vital air and breathe out fixed air, just like a fire will consume vital air and make fixed air, meaning that people also run on combustion.
We're made of fire.
Yeah. Which is like, what the fuck? Which is, I mean, that's pretty fucking amazing when you think about it, right? If you discovered that, would that not freak you out?
Especially if you didn't have it like if you discovered it in the context of knowing so little else about the nature of the world, right?
Yeah.
And so it's, yeah, what you could infer would be through the roof.
Yeah. Why is there fire? What happens? There's obviously no fire inside me, but what?
Yeah, like you put a candle in a jar and it eventually burns out. You put a mouse in a jar and it eventually burns out.
Yeah.
Like why are these things the same?
Right.
Because you don't know what's in the air and you don't know, the parts of it. So, yeah.
Is the fire alive? I don't know. Elias explains matches catch fire because of phosphorus. He breaks down a bit more. I skipped ahead a little. Phosphorus is highly reactive. Pure phosphorus glows in the dark and may spontaneously combust. It's also well suited to its role in ATP, your body's chief method of storing chemical energy. If a match stops working, so do you. For the match to not catch fire when phosphorus is rubbed against something would mean that phosphorus isn't working, which means that our own internal chemical processes aren't working either. They both work off phosphorus.
So I didn't read this fantasy story, but couldn't humans also just run on magic?
I suppose. That's, I guess, how it must have worked.
Yeah.
So that would have been a cool rationalist version of that story.
Mm-hmm.
If, like, Harold Shea had been like, the match isn't working, but then how am I working? And then done some experiments and been like, my body's made of magic.
Yeah.
That would have been cool.
He ends with, phosphorus derives its behavior from even deeper laws, electrodynamic and chromodynamics. Phosphorus is merely our word for electrons and quarks arranged in a certain way. You cannot change the chemical properties of phosphorus without changing the laws governing electrons and quarks. So if you stepped into a world where matches fail to strike, you would cease to exist as organized matter.
This reminds me of, I feel like there's been a couple of stories like this too, but I remember as a kid I had this book of short, like, science fiction stories, And there was this one where there were these two kids that discovered a time machine. And the one kid was cautious and like, we shouldn't use the time machine. And the other kid was like, I was born in the wrong era. I need to live in Victorian times. And then like finally they wrestle over the time machine. The one kid uses the time machine and then she's just floating in space because she's gone back in time to Victorian times. But, you know, everything has been moving this entire time.
Right.
That's also my objection with ghosts. That unless like
Maybe they're affected by gravity, though.
so ghosts must be affected by gravity, I guess, which is weird because they're supposed to be substanceless. And like if you're killed like on the 40th floor of a high rise and they demolish it and make room for like a parking lot, are you just like floating up there, or do you like zip away from the earth when like, you know, the moment you die and like every year the earth swings back, but then of course the galaxy's rotating too, so like you just never really get back to where you were when you died.
I did actually read this story about ghosts where a ghost like there's this girl who could go back and forth between the spirit world and the real world, and she kind of became a ghost when she was in the spirit world, and at one point she's in her dad's apartment in New York and turns into a ghost and just falls through the floor. I love when people actually think about stuff like that.
Yeah, I think Dan Dennett, when he's talking about his, you know, mind stuff and all that, and some of it, because the philosopher of mind, like how can Casper go through walls and catch a ball and play like catch with you?
Right.
So
Maybe he gets to choose which parts of him are corporeal.
that's how like a lot of the ghost movies handle it, right? Movies like Ghost with Patrick Swayze.
Yes. Yeah.
Although he doesn't choose to not fall through the floor, he just chooses to be able to push things over and stuff.
Maybe he's just subconsciously choosing that all the time.
Sure. Well, you'd think you could learn a lot. So like that'd be like the fun way to fuck with somebody who's just recently a ghost, right? Because like
Right.
they can't push things, but it's like you realize like you're doing it to the floor right now. It's like either they gain the ability to push stuff really easily, or they just start falling.
Right.
Yeah, the character in that story actually was like, man, how do ghosts work? How come I could fall through the floors here? Why don't all the ghosts in the world just sink all the way like through the Earth's crust and just stuck in a big ball in the core of the Earth?
I think we just figured out what hell is. All right, we did it. Theology solved.
I guess if you like take a completely relativistic view of the universe, I mean, sure, maybe we're moving, but there's no difference between that and everything else moving around us in relativity terms, right? So maybe the ghosts are just like really, really into relativity. They're like, I believe I am standing still and everything else is moving relative to me.
Yeah, things are moving in some sense, though. I mean, the universe is expanding. It's not like it's all relative. I mean, it is relative. Never mind.
Your decision whether or not it's relative doesn't impact whether or not it is, right? So like
No, it's still relative.
right, but that's what I'm saying. Your understanding, your decision to like accept that doesn't change whether or not the universe is relative.
Mm-hmm.
So I guess
It's not like an observer phenomenon in the sense that you're controlling
Right.
the...
Like we're moving relative to the sun, and the sun is moving relative to us, and how we choose to think about it is just how we choose to think about it, right?
right, but not what we choose. Like not our ability to interact with it isn't determined by our understanding of that, right?
Yeah, but there's no universal 000 coordinate.
But I'm saying that if you're a ghost,
They shouldn't be able to choose that either?
You shouldn't be able to choose that either.
Yeah, well,
yeah,
maybe that's the one magic power as a ghost.
that's fair.
All right, universal law.
Someone else do this one.
I got it.
Cool.
It was one of the most startling unifications in the history of science, for it brought together the mundane realm of matter and the sacred realm of life, which humans had divided into separate magisteria. So this is referencing
The prior post.
the fire. The first great simplification was that of Isaac Newton, who unified the course of the planets with the trajectory of a falling apple.
Which, by the way, I didn't realize was as big a deal as it was, but apparently people had a really big thing between the world of the mundane down here and the world of the heavens above, which was like God's domain. It was like supposed to be a completely separate thing.
Yeah, I mean, like, they actually literally thought heaven was above the clouds in the sky somewhere.
Right.
In that, like the stars were implanted on a dome around us, right? And like things are like, or separate domes that you could like, you know, they're rotating in weird ways.
Well, depends on how far back you go. At one point, yes. I'm not sure what they were thinking in Isaac Newton's time at that point. They may have still be doing the dome thing.
Depends who you mean by they.
Right.
There's a lot of people alive in Newton's time.
Yes. But the most important thing is that, like, they're literally two different planes of existence, right? It would be, I don't know, like the spiritual world and the real world. Like, this is the real world. It's like the Matrix, right? As opposed to the world outside the Matrix. They're completely divorced, and trying to prove that the two were the same thing was just crazy.
Mm-hmm. Newton's discovery gave rise to the notion of universal law, One that's the same everywhere and every when, with literally zero exceptions. Human beings live in a world of surface phenomena, and surface phenomena are divided into these leaky categories with plenty of exceptions. The only time when it seems like we would want a law to hold everywhere is when we're talking about moral laws, but even here there's exceptions. The idea of a rule with literally no exceptions seems insanely rigid, the product of closed-minded thinking by fanatics, so in the grip of their one big idea that they can't see the richness and complexity of the real universe.
Which, did you guys get that a lot in high school too, with people?
A lot.
Yes.
You still see it now with, the White House saying that, the established scientific criterion or scientific consensus on climate change has nothing to do with the truth.
Yeah.
So,
But I meant not just in terms of science, but in terms of like, well, you're just such a rigid nerd, you can't even understand that other people could be different.
I've got that a lot with people talking about like spiritual phenomena or like astrology or whatever. It's like, well, we can't know everything.
Yeah.
Science, like that, people, scientists think they know everything. They're just so closed-minded.
Yeah.
How can we ever really know what's true?
and yet you're going to sell me a book that tells me exactly where outside the box is. Great, thanks.
Yeah,
Right.
but this is your chakra positions. These are the correct ones here.
Yes.
So, this is the customary accusation made against scientists, the professional students of the richness and complexity of the real universe. Because when you actually look at the universe, it turns out to be, by human standards, insanely rigid in applying its rules. As far as we know, there's been not one single violation of conservation of momentum from the uttermost dawn of time up till now.
I think this is brought up in the post too, and I didn't copy it, but sometimes when I get into arguments with religious people about what God actually cares about, and people say like God wants us to be happy, God doesn't want us to be suffering or dying, or
Have they seen
God-
the world?
right, yeah, God dislikes gay people. I'm like, look, God made suffering. God made gay people exist. You know what God really fucking cares about?
Beatles.
No, well, I mean, what God really cares about is that no one be able to move faster than the speed of light. Because you can't. If God was all powerful and really cared about something, you just couldn't do it. Much like the speed of light.
I like that. And the Beatles joke is because there's, 140,000 different species of beetles?
I think like 70% of all biomass is beetles or something like that. I'm not sure if that's the exact number, but like
It's stupid.
there's a lot of beetles.
Hundreds of thousands of species. Yeah, I think it's more than 140,000.
I don't think we're the chosen species. God's a beetle. The
Ooh.
Egyptians were right.
Did
Oh, wait, well, I'm thinking about the beetle rolling the sun across the sky. They had
Oh.
multiple gods, though.
Yeah.
Anyway, sometimes, very rarely, we observe an apparent violation of our models of these fundamental laws. Which, yeah, my dad's like, scientists are wrong all the time.
Mm.
If you'd learned to think like reality, then here is the Tao. Since the beginning, not one unusual thing has ever happened.
Yeah, fantastic.
Yeah, I love it. And then rolling with the theme of thinking like reality. That's the name of the next post, Think Like Reality. Reality has been around since long before you showed up. Don't go calling it nasty names like bizarre or incredible. The universe is propagating complex amplitudes through configuration space for 10 billion years before life ever emerged on Earth. Quantum physics is not weird. You are weird. Human intuitions are produced by evolution, and evolution is a hack. When you go down the fundamental level, the level on which the laws are stable, global, and exception-free, there aren't any tigers. The fact that there aren't any persistent objects bouncing around in three-dimensional space. Deal with it. Probability theory tells us that surprise is the measure of a poor hypothesis. If a model is consistently stupid, consistently hits on events that assigns tiny probabilities, then it's time to discard that model. A good model makes reality look normal, not weird. A good model assigns high probability to that which actually is the case. You want to reshape your intuitions so that the universe looks normal. You want to think like reality.
I still have trouble with that, but I do find I'm less surprised than I used to be since I've adopted this rationality thing.
Can you give any examples?
The example that most jumps to my mind is a time when I actually was very surprised, which was when Trump was elected. Like, I was shocked by that, which means that my model of American society was just way fucking off.
Yeah, a lot of people said that in response to that. I mean, like people in, this community.
Yeah.
Well, it happened, so clearly,
clearly my model was wrong.
Yeah, all of our models were pretty wrong.
So we have to update our models, yeah.
Yeah.
Like to say, I can't imagine what it'd be like to say, no, my model was right, the reality was wrong. That's not a very scientific or rationality-oriented way of thinking about things.
It seems like, at least in regards to the politics thing, a lot of people are like, I think I was right all along. There was just this one special exception this one time, and like they come up with excuses. It's like, no, man, if you were that surprised by things, your model was off. You were failing to account for a significant thing that turned out to be rather important.
I know one thing that Julia Galef either does or did was keep a surprise journal and just,
That's a damn good idea.
yeah, like even if it's little tiny things, like, oh, I didn't expect that to work, or
That is a really good idea.
yeah,
I've been trying to do the calibration, assigning probabilities, like random kind of vast numbers to things, and then using that as my anchor to update on things when you're right or wrong. But like, it's often really hard to do that in real life because real life doesn't come with numbers.
and like there's a lot of things happening that you wouldn't have like thought or like took the time to predict in advance. So one thing you can try and do is just train yourself to notice that feeling of surprise,
Yeah.
and then be like, oh, okay, what just happened? What made me feel that way? And then you can assess those after the fact when there's downtime to think about it.
Yeah, you can count how many times you were surprised and see if it decreases over time. Because, the other thing with the calibration exercise is that, like, often the thing you're surprised about doesn't come up again. So if you're like, oh, okay, I was giving that 40%, I guess I better up it to 60. Trump's not going to, well, I was going to say Trump's not going to get elected again, so...
Do you actually think that he's not going to get elected again?
Oh, I don't know.
Oh, okay.
I was trying to think of an example of like something that was really surprising that might not, that is very unlikely to come up again, but that was a bad example.
I should bet each of you $200 that he does.
So that you get $400 if he does?
Right. So that way...
But then I'm screwed because he's
that's like
president and I'm out $200.
That's a win-win for you, Stephen. I see what you're doing.
Right. So that was, I think, Stephen Hawking's thing. Like, he wanted to bet somebody that black holes weren't real.
Oh, right.
So at least in that way, he'd have won the bet if he was wrong. So this principle extends beyond physics. Have you ever caught yourself saying something like, I don't understand how a PhD physicist can believe in astrology? Well, if you literally don't understand, this indicates a problem with your model of human psychology. Perhaps you are indignant. You wish to express a strong moral disapproval. But if you literally don't understand, then your indignation is stopping you from coming to terms with the reality. It shouldn't be hard to imagine how a PhD physicist ends up believing in astrology.
I actually just said I literally don't understand how people cannot accept the transporter argument.
Yeah, and we need to update our vocabulary in this community to be like, I strongly morally disapprove of the fact that people think that the transporter argument.
No, I actually literally don't understand why people don't get the transporter argument, which means I have a serious hole in my models of other people's psychology.
Right. It's not. Yeah. So that's
Compartmentalization.
But that's good to know, right? So now you can actually wait. This is actually a problem with me not understanding them, not a problem with them for being inscrutable.
Right.
This sounds like something that you can figure out.
I should hope so.
Yeah. So I now try to avoid using the English idiom, I just don't understand how, to express indignation. If I genuinely don't understand how, then my model is being surprised by the facts, and I should discard it and find a better model. There are no surprising facts, only models that are surprised by the facts.
Nice.
Which is a nice way to frame things, right? So,
yeah. Always working to get better models. Always working for our models to be a little bit less wrong.
Totally.
Wait a
minute, that's the name of the show.
Yeah, I don't know if it's the number of times that I've read these particular ones or these are particularly good sequences, but I feel like there wasn't much to say about any of these three, kind of just like a fist pump, yup.
Mm-hmm. Yeah, these ones are poignant. I think that's probably why you selected them for episodes in the Methods of Rationality podcast, was because these ones don't require a lot of extra backlog or discussion or anything like that.
Yeah.
It's no, you read this and you basically get what it's saying.
Yeah.
Yeah.
Also why I had 3 of them in this episode, because I knew we'd get through them pretty fast.
And they're all coherent.
Mm-hmm.
So
they all had one theme that they were hitting. Yeah.
Exactly.
For next time, we will be talking about the posts Beware the Unsurprised, The Third Alternative, and Third Alternatives for Afterlife-ism.
Dope.